All right, we're going to start going over the next 5 problems of the 2017 geometry exam. Let's go to number 11. And I want you to write this down, but let's actually read the question. So it says a solid metal prism has a rectangular base with sides of 4 and 6, all right? And a height of 4. So the dimensions are 4, 4, and 6. All right, a hole in the shape of a cylinder with a radius of 1 inch is drilled through the entire length of the rectangular prism. So you have to imagine that something was drilled, but it went all the way through to the back. Okay? Now, what is the question? It says, what is the approximate volume of the remaining solid in cubic inches? So you have to imagine taking this entire rectangular prism, all right, and drilling a hole, and what would be left after you drilled this hole? So it would basically be all this that's around it. So what we need to do is find the volume of the whole thing, the volume of the whole prism, and then find the volume of the cylinder, and then subtract the volume of the cylinder from the volume of the whole prism. So the volume of the whole prism, the entire prism is this one. Now I want you to write this down. Rectangular prism is length times width times height. So that's pretty easy. That's just going to be 4 times 4 times 6. So 4 times 4 times 6, which is equal to 16 times 6, which is 96. Now, the volume of a cylinder is pi radius squared h. So that's going to equal pi radius squared. Well, our radius is just going to be 1. And our h in this case, you have to imagine if I were to stand this prism up, the cylinder would be something like this, but the height would actually come from that 6, because that's how far across it is. All right, so when you put in the height, it's going to be 6. So the volume of our cylinder is really 6 times 1. We could just write that as 6 pi. All right, so now we're going to do 96, which is the volume of the hole, minus 6 pi, which is the volume of the cylinder. So sometimes you have answers that still have pi in them. In this one, you don't have that. So we need to go to our calculator. And we're going to do 96 minus 6. Now pi is actually activated when you do second and then this button. And you end up with 77. So let's go back. Is that one of the answers? Hopefully it is. And it is 77. All right, so that's question number 11. Okay, moving on to question number 12. It's pretty much as straightforward as you're going to get on this problem. I mean, you're not going to get any more straightforward than this problem. All right, so what are we looking for? It says, given the right triangle, what is the value of x? Okay, so I want you to write this down. To find the side of a right triangle, so because x is a side, you're either going to use one of two things. You're going to use Pythagorean theorem or SOHCAHTOA. Since we know one of the sides and one of the acute angles, we're going to have to use SOHCAHTOA. So sine, cosine, or tangent. Right, so I'm going to look at my acute angle. I'm going to label my sides opposite, adjacent, hypotenuse. Okay, I'm looking for the hypotenuse. I have the adjacent. That means I'm dealing with hypotenuse and adjacent. That means that I'm dealing with cosine. So you're going to have the cosine of 40 is equal to the adjacent over the hypotenuse. That's going to be 14 over x. Then I'm going to say x cosine of 40. Remember, when the x is on the bottom, that's when you have to do the extra step of dividing. So I'm going to divide by cosine of 40, divide by the cosine of 40. So now, on my calculator, I'm going to go and make sure it's in the right mode. It's in degree mode. That's good. So I'm going to come back, and I forgot what I need to type. 14 divided by, so x is going to equal 14 divided by the cosine of 40. So to do a fraction, I do alpha y equals enter. I'm going to do 14 divided by the cosine of 40. And we have 18.2. Let's go back to the answer. And to the nearest foot, well, to the nearest foot would be 18. All right, on number 13, it says on the graph below, point A, 3, 4, and segment BC with coordinates 4, 3 for B and 2, 1 for C are graphed. And our question is, what are the coordinates of B prime, C prime after BC undergoes a dilation centered at point A with a scale factor of 2? So that means our new line, because it's a scale factor of 2, that means our new line is going to be bigger. So what I'm going to do is I'm going to draw a line out here, and from A, because it's centered at A, and I'm going to draw a line here, and I'll be right back. Okay, get back to where we were. Since you have a line being dilated with a scale factor of 2, that means your new line is going to be longer than your original. So let's go ahead and do it. If you were to do it or dilate it with a scale factor of 1, you would actually end up with the same exact line, right? What you want to do with a scale factor of 2 is just count or use the slope from one point to the other and then do that twice. So if I go from A, if I go down and over, then I just want to go down and over. That's a scale factor of 2. So that would be my B prime. And then from A to C, I go down and over, down and over. So this would be my C prime. And you look at your choices here, and it looks like our points would be, which one of those is it? B is going to be 5, 2, so we can eliminate those, and C is going to be 1, negative 2. So there we go. Okay, looking at number 14, it says in the diagram of right triangle ADE below, BC is parallel to DE. Now, I want you to write this down. This statement, what this statement shows or tells us is that the two triangles are similar and that their corresponding angles are congruent. So that means that this triangle and this triangle are similar. Right? So they are similar. Now, and the reason why we know that is because if BC, right, is parallel to DE, and you have a line going through here, that means that these would be corresponding angles, right? Let's see. First of all, they both share A, so we know that that is congruent. And if those are parallel, that means that this angle and this angle are also congruent. So 2 out of 3 means they're similar. Also, the third one would also be congruent. All right, so now, what do we have to do here? So take a second and look at the problem. Okay, we're looking for which ratio is always equivalent to the sine of angle A. So we're dealing with angle A. All right, remember sine is going to be, sine is the ratio of the opposite side to the hypotenuse. And I want you to write all this down also. You need to write all this down that I have here. Okay? So the opposite side to the hypotenuse. So it's either got to be the blue triangle, which would be, let's see, I'm going to erase some of this. Well, the opposite side or the hypotenuse of the bigger triangle here would be DE over AD. For the smaller triangle, it would be BC, this one, over AB. And if you look here, BC over AB is that one. All right, let's go to number 15 here. All right, something we have not seen in this class, or depending on when you watch this video, we have not actually done anything with some of these terms you're about to see. All right, so I want you to write down this definition here. And I'm going to show you this picture of how this matches the question. So it says, in circle O, secants, ADB. So ADB, this is a secant right here. This is a secant. All right? And AEC are drawn from external point A such that D, B, E, and C, so D, B, E, and C are on circle O. So these points are all on circle O. All right? If AD is equal to 8, and AE is equal to 6, and EC is 12 more than BD, so the length of BD is. So when it says EC, so EC is this one, EC is 12 more than BD. So I called my BD X, and if CE is 12 more, or EC, then that's just going to be X plus 12. Now, there is a formula, and it's the wee-wee formula. We call it the wee-wee formula, and I'll tell you what it means. Okay? I'm going to write down what this means. It means the whole times the external equals the whole times the external. Okay? And this is, when you have two secants coming from an exterior point, this is a formula we can use. So the whole up here is going to be both of these sides together, so that's going to be X plus 8. Now, what's the external part? The external part is just this part that's on the outside of the circle. So we're going to have the whole, which is X plus 8, times the external part, which is 8, is equal to the whole. Now, the whole here is going to be X plus 12 plus 6. So it's actually X plus 18. Right? That's the whole. I don't want to forget the external. So that's going to be times 6. All right, so now we go ahead and just solve for X. And BD is actually going to be our X. So we have distribute. We have 8X plus 64 is equal to 6X plus 6 times 18, I believe that's 108, is that right? 108. 60 and 48 is 108. And then we just go ahead and solve for X. So I'm going to take away 2X, take away 2X. So I'm going to have, take away 6X. What am I doing with 6X? So it's going to be 2X plus 64 is equal to 108. Now I'm going to take away 64. take away 64, and you have 2x is equal to, what's 108 minus 64? That is 36, 44, yeah, it looks like 44. I'll just use the calculator just so I don't make any mistakes. 108 minus 64. 108 minus 64 is 44. So 2x is equal to 44. Then divide by 2 and divide by 2. And x is equal to 22. All right, x is equal to 22. That's an answer here. There we go. Always make sure that we're, because sometimes they'll do that, then they'll say, what's the length of CE? So if this is 22, then you'd have to go 22 plus 12, and that'd be 32. So just be careful with that. They like to throw tricks like that at you. All right, so that's it for problems 11 through 15.